Good evening. Is my voice audible?
Yes, sir.
Today we are going to discuss previous year questions asked from area bounded by region topic, and it is based on application of definite integrals. Okay. So before going ahead, let us discuss some important concepts which will be required while solving previous year questions and how we have to approach these questions in the exams. So like there are previous year questions and it have like definite integration. We have to find the area bounded by region. So for that, we have to draw the graph. That the thing here is, it's not compulsory. It's not compulsion for you to draw the graph every time. And if you know how to draw it, please go ahead and draw it roughly. After first, before like if you have multiple functions, first calculate for their intersection points. And according to those calculations, what will you do? If you are able to draw graphs, so before doing that, the first step is to find out the intersection points. After finding them out, draw graph in rough manner. Okay. I'm not sure about the spelling. After drawing, if you can draw, otherwise, if you are unable to draw, leave it, no problem. Second step, in this, if you're not able to draw the graph, then you have to find out the intersection points. It's must. After finding intersection points and go ahead accordingly, integrate the function from the given intersection points in the applicable. It can be also a function in y. Okay, so just you have to find out the integration of the given limits. If you have find out through the graph, it would be better. Otherwise, you can also take an idea from just finding the intersection points. There's one thing important to note over here, that you have to consider this fact uh, while leaving and while dropping the option to draw the graph, that that curve must not go under the x-axis or the y-axis. Otherwise, let's say if the curve is like this, so if you are integrating this function, you have find out the intersection point from here to here directly, then you will be missing out that this area A1 and A2 will be getting subtracted. So for that, you need to be very cautious that whether the curve is not changing axis. If it is, then and even if you will be finding out intersection point of this axis, let's say y is equals to 0 or x is equals to 0, then be very sure and be very cautious while finding the intersection points, whether they are 2 or 3, okay, or 4 or 5. So you have to note those points, and then you can go ahead and simply integrate the function. Drawing graph will make things easy for you. Okay. And here, as I do it like using these tools, you do not have to draw these kinds of professional or sophisticated graphs, because here it's the requirement of me to make it more understandable for other candidates and students who will be watching the video and the class. But in the exam, you have to just understand by your graph only. There's no one else. So just draw a graph which you will be able to understand. That will be good enough for you. Everything clear?
Yes, sir.
Going ahead, discussing the first question. What is the area bounded by the curve and the x-axis? Now here, as we can simply see, there is a curve in the x-axis. So x-axis is equation is y is equals to 0. So let's find out the intersection points first. 0 is equals to 4x minus x cube, x square minus 3. Multiplying minus sign on both sides, so 0 will become 0. It will become 0, x square minus 4x plus 3. Now its root, two numbers for which the equation has a sum of plus 4 and multiplication of 3. So 3 and 1 simply. If we will add these two numbers, so this is going to just if just give us 4. Okay, and if we multiply these, so it will give us 3. So we can re-represent this form in this form. Yeah, it is the same quadratic equation. Now taking x common. Now taking x common, x minus 3, taking minus 1 common, x minus 3. Now taking x minus 3 common, x minus 1. So the roots are x is equals to 3 or x is equals to 1 for both. So now we have intersection points 1 and 3 and the for y is equals to 0. So here y is equals to 0, here y is equals to 0. So there are two intersection points. So I guess there is no a particular problem about the curves getting or changing its sign. So we can directly integrate the function f of x and dx, and from x is equals to 1 to x is equals to 3, and that should give us the area bounded by the curve. Going ahead, integrating it, 4x minus, let's take simplified version. No, let's take this only. Yeah, minus 3. That was equals to 0. This was the case when we were equating y is equals to 0 for the x-axis. Now taking the functions integration from 1 to 3. It's 4x integration will become 4x square by 2. X square is integration x cube by 3. 3 dx becomes x, upper limit 3, 1. Now this cuts 2x square, 2 into 9 minus x cube by 3, 3 cube by 3, 3 square 9 minus 3 into 3, again 9. So this comes out to be 2 into 9, that is 18, minus 9 into 3 into 3, 9. It comes out to be 0. We are missing out on something. 4x square minus x square minus 3. So 4x square by 2 minus x cube by 3 minus 3x. 4y is equals to 0, and from 1 to 3, 1 to 3. That's correct. It's correct. X cube minus 3x. 2 into 9 minus 3. Okay, yes, what we are missing out is we have only substituted this function for x is equals to 3 minus, also there is 1. So 2x square becomes 2 minus x 1 by 3 minus 3 into 1, that becomes 3. So this has become 0. This particular becomes 0. Minus of 2, minus of minus 1 by 3 becomes 1 by 3 plus 3. So this is now 3 minus 2 plus 1 plus 9. 9, 10, 8 by 3 should be our answer. 10 minus 2, 10 minus 2, oh, minus 2 into 3 will become minus of 6. So 10 minus 6 by 3. 10 minus 6 becomes 4 by 3. So B should be our answer. Let us check first. Yes, it is the case. And now, so what we have done in this question, there were two curves. So for two curves, one was a parabola, another was a straight line, that was the x-axis. So we have taken the function of the x-axis, that is y is equals to 0. We have find out the intersection point. These were the two, and we have applied on the integration of function with respect to x from 1 to 3, and then we have solved it for. And after solving for the integration, we have substituted the upper limit minus. Then we have substituted x is equals to that is lower limit, and then we have solved for the answer. Is this clear? Any doubts?
No, no doubts.
Okay. So this is another question. What is the area enclosed between the curves y square is equals to 12x and the lines x is equals to 0 and y is equals to 6. So x is equals to 0 is basically y-axis. So I have drawn it using this representation. Y is equals to 6 is another straight line, and this is the curve y square. Now first, this graph will not be given to you. So how will you find out? Y square is equals to 12 of x. For any value of x, for any value of x, for any value of y, x will be positive. X will always be positive because y square by 12. For any value of y, you will get x always positive. So the parabola will face positive of x, and it will cover all the values of y, negative and as well as positive. Thereafter, we have this x is equals to 0. So for finding x is equals to 0, intersection points निकालते हैं. X is equals to 0, y will also be 0, y square is equals to 12 into 0, that will become 0, y square is equals to 0, then y is equals to 0. And for y is equals to 6, 6 square 36, 12x, x will be 3. So this point will be 3 in 6. So, and if we draw a perpendicular over here, this point will be,
Yes, sir.
yes, this point will be 3, 0. Y will be 0 here, and 3 will be the x coordinate here. So now we have seen the graph. This is the line y is equals to 6. This is the parabola y is equals to 12x. This is the y-axis. Now the area bounded is this. So we can go with two methods. One is that we can simply integrate the function of parabola from 0, 0, like from in terms of y, so that we'll be able to finding the area under the curve with y-axis. Then we have to integrate the function in terms of y variable from where 0 to 6. Or what we can do is we can find the area under this curve, like this shaded region, and then we will find out the area of this rectangle, and then we'll subtract it from the shaded area. So we have two methods to do. Please tell me using which one we solve now. Anyone, pick anyone. Yes, Yazini.
So,
Pick any. Akkad bakkad.
sir?
I was saying ki you can pick any of the method, first or second.
Second one, sir.
Okay. So in this, we have to first find out the area of rectangle. This arm is 3, this is 6. So area of rectangle will be length into breadth minus of area of shaded region in terms of x from 0 to 3. So answer will be 18 minus the function in terms of x will be 12x square root from 0 to 3. Now this is 18 minus square root 12 outside, integration of root x half plus 1, that will make it 3 by 2, and the limit on this is 3 to 0. For 0, it will simply become 0. So substituting the upper limit 2 by 3 into 3 into, because 3 raised to power 1 into 3 raised to power half, that is root of 3. This is cancelling each other, and solving for 12. Root of 12 can be written as 4 into 3. So 4 square root is 2, root 3. So we can represent this as 2 root 3. Now root 3 and root 3 into root 3 will make it 3. So 18 minus 2 into 2 into 3. That is 4 into 3, 12. 18 minus 12. 6 square units should be our answer. Is this matching? Yes, it is matching. Option number C should be our correct answer. Let's check. Yes, it is so. So is this question clear to you?
Yes, sir.
We have also gone with this method because this would be more simpler. For finding its value, first we need to find out x here, y square by 12, and then can simply, we have now the function of the curve in y terms, integrating this so 1 by 12 integration of y square by 3 by 3 and limit from 6 to 0. So this will become 1 by 36 into y cube. So 6 cube minus 0 cube, so that will be 0 only. So let's neglect that. 36 into that 6 will remain. So this will be our answer. So this would be more simpler. This is also simpler. Anyway, whichever way you prefer, that will give us the correct answer. Clear?
Yes, sir.
Okay. They have also solved using this method, which we have solved first. Okay, so coming to the next question, what is the area under the curve fx is equals to x into ex above the x-axis between the lines x is equals to 0, x is equals to 1. Now, do you know how to draw the graph of x into e raised to power x? Please respond. If you don't, please tell that. I'm expecting that.
No,
Yeah.
sir, actually. No.
Yeah. So what we'll do, we'll ignore drawing graph here. Simply, we have the function and we have two lines. So first, find out intersecting points for x is equals to 0. Y will become fx is y. We can represent fx as y. So y will become 0. This is one intersecting point. For x is equals to 1, y will be 1 into e raised to power 1. That is simply e. Y is E. So now we have two intersecting points under and the area bounded by these two limits. And so we can take the integration of f of x in the function with respect to x as a variable. So from 0 to 1, this should give us the area bounded. Now moving ahead, the integration will go like this. Now this is the integration. This integration will be solved by integration of parts formula, which is islet. In this, this is algebraic function. And this is exponential function. So now, first function would be not, there is no inverse trigonometric function, there is no logarithm, there is algebraic. So this would be our first function. Okay, let me revise you. Let me write the formula. This integration of second minus integration into first derivative into integration of second and into integration of whole. So this is our formula. Now here, first function is x integration of ex minus, let's name this integration as I. So I is x integration of ex minus of integration of derivative of first derivative of x is simply x. Integration of second integration of ex then whole integration. X integration of ex is simply ex minus integration of ex will be ex and integration of ex further will also be ex. Okay. So now this is the integration x. E raised to power x common x minus 1. This is our integration. Now there is a limit on this from 1 to 0. So first putting 1 e 1 minus 1 will make it 0 minus of e raised to power 0 to 0 minus 1. So this has become 0 minus e raised to power 0 is 1 only. So let me write in the next page. Where is the next? So e raised to power 0 minus e raised to power 0 into 0 minus 1. So anything raised to power 0 will make it 1. So this is 0 minus 1 into minus of 1, minus 1, minus 1, make it a positive 1 square unit. Should be our answer. Let's check. Yes, B is in options. And yes, it is the correct answer. So is this question clear to you?
Yes, sir.
Okay. Have you ever wondered that why anything raised to power 0 is 1?
No, sir.
Have you ever wondered why 0 factorial is 1?
No, sir. And we just study whatever they give and we just will do that. That's
Okay. So do you want me to answer it?
yeah, sir.
Okay, so let's discuss this. We have time. So first of all, let's talk about powers. So let's talk about 1 raised to power. Let's talk about 2's power. We know it well. 2 raised to power 1 means, please respond.
Yes. 1,
2.
2,
That will
4,
become 4. That will become,
8,
that is,
or 16,
yes, that is,
32.
that is. So what is happening over here, that we are multiplying the two here. We have multiplied 2. We have multiplied 2. We have multiplied 2. We have multiplied 2. We have again multiplied 2. Right?
Yes.
So it's a pattern. For increasing power, we are multiplying 2 because 2 is our base. We are multiplying the base. So when we will decrease the power, okay, when we will decrease the power to, then what we are doing here is that we are dividing it by
Divide
2.
2.
Dividing it by 2. So 32 by 2 is 16. 16 by 2 is 8. 8 by 2 is 4. 4 by 2 is
2,
2 by 2 is,
1.
got it?
Yes, sir.
And that's how 2 raised to power minus 1, then 1 by 2 is 1 by 2. And similarly, it goes and on and on. Same goes, same kind of logic is with factorials also. 1 factorial is 1. 2 factorial is 2. 3
2,
factorial is 6. 4
6,
factorial is 24. 5 factorial is, what is 5 factorial? Oh, tell me 6 factorial. 720.
720.
Yeah. So what we are doing here is, for going here to here, we have multiplied the 2. We have multiplied 3. We have multiplied 4. We have multiplied 5. We have multiplied 120 into 6. Right? For going back, we have divided by 6. For going back, we have divided it by 5. For going back, we have divided by 4, by 3, by 2, by, say, we will divide 1 by 1. 1 by 1 will become 1. Hence, 0 factorial is 1. So this is a reverse logic. Now we can wrap our head around it. Why a anything raised to power 0 is 1 and 0 factorial is 1. Interesting?
Yes.
Yes, let's go back to integration. Yeah, so our answer is also correct. So this is considered the line, this is a line and the circle. Now we know how to draw the graph of circle and line. That is very simple. So before drawing the graph, let's first find out the intersecting point as per our method. So the curve is this, and x is equals to √3 of y. So substituting the x √3 y square plus y square is equals to 4. Y square √3 becomes 3 plus y square equals to 4. 4y square minus 4 is equals to 0. You have taken this 4 to the left hand side. Taking 4 common, y square minus 1 is equals to 0. 4 will get vanished when it will go under 0. So y square is minus 1 is equals to 0. So a square minus b square can be written like this. And now y can be plus 1 or minus 1, either or both. So we have now find out the value of y. So let's take for y is equals to plus 1, x is root 3. For y is equals to minus 1. Oh, thank God, y is outside the square root. So for y is equals to minus 1, x will become minus of root 3. So these are our two intersecting points. So we know by calculating for the intersecting point, and there is some rational and real. So there is some real numbers, real coordinates which are coming out. So it is sensible from these calculations that circle will be getting intersected by the line twice, right? So let's draw the graph. Okay. And there is a circle. Why there is a circle? Because we know about the general. I hope it's yes. So why it is a circle? Because from the equation we can make out x square plus y square is equal to 4. So it's a general equation of circles. The general
X minus h the whole.
circle. Yes.
No, I was just saying the formula of that. That's also.
Oh, could you repeat?
No, x minus h the whole square. That formula plus y minus k the whole square is equal to r square.
Yeah, good. So here on comparing, we know h is 0 here, k is 0 here, and r is 2 here. Okay. So the radius is 2. The radius is 2. So this distance is going to be 2. So if this is 2, this coordinate will be 2, 0, because y's value on x-axis is 0. This will be, please speak, x value is 0 and y's value will be, because this distance is also because the center is on 0 0 origin, so this distance is also 2, this is also 2, this is also 2, this is also 2, right? So this coordinate will be
2.
0 2,
0.
yeah. This will be 0 minus 2, this will be minus 2 0, this is negative x, it's positive x, it's positive y, it's negative. Now we have a straight line which is x is equals to root 3 of y. Yeah. So representing this equation like this, x by root 3, and there is a straight lines equation, general equation mx plus c. So here the intercept is 0. This is the straight lines equation where c is the intercept on y. Intercept means where the straight line is cutting the y-axis, where the straight line is cutting the y-axis, that is our intercept. So this is 0. So means the if straight line is passing through origin. As we'll put the x is equals to 0 here, so the y will also be 0. So one point of straight line is clear to us, which will be the origin. And let's find out the intersecting point between this. We have already found that, right? The intersecting point is these two. So these two, both y and x are positive. So y and x will be positive in which quadrant? This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. In which quadrant y and x both will be positive? So will the point lie here? Will the point lie here? Or should the point lie here or here?
First quadrant.
First, very good, very good. So the point can be anywhere. Let's do it roughly. And if this is a straight line, so the straight line will go something like this, passing through both the points, passing through both the points. Yes, now it's passing through both the points, and it is also intersecting the circle once more. So the both here x and y both will be negative. So let's take those value minus root 3 and minus 1. minus root 3 and minus of 1. And here plus 1 and plus root 3 and plus 1. These are the coordinates. Now we have to find out the area. The first question reads, what is the area of the region in the first quadrant enclosed by the x-axis and the line this and the circle? Okay, so the yeah. So the area enclosed in the first quadrant by the straight line, by the circle and the x-axis. So this is should be the area which we should discuss about. Why? Because this is a straight line, this is a straight line, this is our circle, and here is our x-axis. So now this is the area, not this one. Is this clear?
Yeah, sir.
Yeah. So for this, we can simply use our geometrical skills. Let's do a perpendicular over here. Okay. So now we can see this is a right angle triangle, and this point should be root 3 and 0. And this is a right angle triangle. This base, the height, base of the right angle triangle is root 3. This height should be 1. And the remaining, we will find out because this particular area is under the curve. Which curve is a circle, right? So we can differentiate the function in terms of x, and from root 3 to 2, simply to 2. So this area plus the area of this right angle triangle should give us the answer. So the area of right angle triangle should be half into base root 3 into 1. It is root 3 by 2 square units. Now let us find out the area of that curve, area under that curve. Okay. So our equation was x square plus y square is equals to 4. Let's represent this in terms of x only. Let's find out the y. 4 minus x square. This is now. So now the integration of function with respect to x from root 3 to 2. Now we know this is a form of square root of a square minus x square. So we remember the formula x by 2, the same whichever it is given, plus 1 a square by 2 sine inverse, because it's in somewhat manner 1 minus x square. So sine inverse of x by a. So now here a is 2, because 4 can be written as 2 square. This is a square, so a is 2. X by 2, so 2 x by 2, 4 minus x square plus a square by 2. A square is 4 by 2, that will come to sine inverse of x by 2. So this is our now integration. There is a limit also from 2 to root 3. So let's put 2 first. On putting 2 first, 2 by 2 will become 2 by 2 will become 1, and 4 minus 2 square will be 4 minus 4. That will be, it will make the first term as 0. Understood?
Yes, sir.
Make the first term is 0 plus 2 into sine inverse of x by 2, that sine inverse of 2 by 2, that will be 1. Sine inverse of 1 is pi by 2 minus, now putting x is equals to root 3 by 2. 4 minus root 3 square minus 4 minus 3, square root of 1 will be 1 simply. 2 into sine inverse of root 3 by 2, root 3 by 2, 4. This is like 30 degrees should be the angle. And if it is 30 degrees, so pi by 6. Skirts by 3. And this also put this. So pi minus root 3 by 2 plus pi by 3. So this will make it as 4 pi by 3 minus root 3 by 2 plus the area of right angle triangle was root 3 by 2. Wow. Now the required area plus root 3 by 2. We are adding the area of right angle triangle. This cuts this. So 4 pi by 3 square unit should be our answer. No. It's not the case here. Area of the region in the first quadrant enclosed by this line in the circle. We are doing it right. The area of triangle should be root 3 by 2. Okay, root 3 by 2. Yeah. About the area of circle. So x square plus y square, 4 minus x square. So it should be in square root of a square minus x square terms x by 2, 4 minus x square plus a square will be 4 by 2, will make it 2, sin inverse of x by 2, 2, 3. So now substituting for x is equal to 2, 2 by 2 will make it 1, 4 minus x square, 4 minus 4 will make it 0. Correct. 2 into sine inverse of x by 2. Sine inverse of 2 by 2 will make it sine inverse of 1, which will be pi by 2. Correct. Minus root 3 by 2, 4 minus 3, 1 simply cancel. 2 sine inverse of root 3 by 2. Root 3 by 2, oh, we have made a mistake. Sine of 60 degrees is root 3 by 2 and cos of 30 degree and cos of 30 degree is root 3 by 2. So here the answer, here the pi should be 2 pi into 2 into pi by 3 should be the figure here. So 2 into pi by 3. So here it will become 2 by pi by 3, 2 pi by 3 plus 3, 3 pi into 5 pi by 3, will be 5 pi by 3. Now, yes, and minus root 3 by 2. So still it should be like this 5 pi by 3 minus root 3 by 2. And the area of right angle triangle is root 3 by 2. So it should make it like this only. So we can calculate this also the area of sector. First, for that we have to find out the theta. So here tan theta would be 1 by root 3 perpendicular base, and tan theta is 1 by root 3 on theta is equal to 30 degree. Now finding the area of sector theta by 360 into pi r square, right? 30 by, this is 30, right? 30 by 360, 0, 0 cancels, 1 by 12. So pi by 12 into r square, which is 4. Now this should be pi by 3. The answer should be pi by 3. Now it is not in the options. So solving for this, the area enclosed by the line in the circle in the first quadrant is pi by 3. Okay, this is correct. Now area of PAB, it's PAB is pi by 3 minus root 3 by 2. Okay, so I guess, yes, we have done a mistake. Minus into 2 pi by 3, there's a minus sign. So 3 pi minus 2 pi, it will make it as pi by 3. So after doing that, pi by 3 will get the answer for the first, but there's no right option in this. This is a misprint, I guess. There should be D, but the given answer is A, which is incorrect. There should be D. And it is also given in the solution, written solution, that the answer is pi by 3. Okay. So we'll see what the second question says. What is the area of the region in the first quadrant enclosed by this line and the circle? Okay, so this is x is equals to root 3. I guess this is a misprint or something. Okay, so this is in the first question, it is asked the region of this much only, area of circle of this much only. 74th has this question. So this has, we have find out it already as root 3 by 2. Arey yaar. Pi by 3 minus root 3 by 2 as per this solution here. So if we'll solve this further, pi by 3 minus root 3 by 2 and area, yeah, 3 by 2, area of this, and area of this is root 3 by 2. So if we'll add these both, pi by 3 will come out. So its answer should be 1 and its answer should be A. So yeah, it's not a misprint, it's correct. Is this question clear?
Yes.
Yeah, it's a bit complex and long because there are two questions in it. So you will have 5 marks by just solving this graph properly. Okay, and you could also, without going in integration, if you have just drawn this graph carefully, you can simply use this geometrical formula where we find out the area of sector in a circle by this formula theta by 360 to pi r square. So the question was straight away solved by using these two formulas on area of sector and area of right angle triangle. So I was just solving this question using indefinite integration because it was my obligation for you to teach in this manner. Otherwise, in exams, you have to be very smart and use smaller methods, half into base into I. Is this question clear? Is this method?
Yes, sir.
Okay, so let's move ahead. Do you want me to solve this question with other method also?
So other method means without integration.
Yeah, without integration.
Then okay, sir.
Should I solve?
Yes.
Okay. So without integration, you have to just make the diagram first correctly. So let's copy your diagram from earlier earlier work that we have done. Okay. Okay, let's draw a new.
So one doubt that why we use integration every time for like finding these areas and all.
Because in this, like, when the method which now I'm going to use is can be used for geometrical figures which we know about. Like we know the formula of area of sector of circle, but there are some, there are some functions like this, x into ex. We don't know about their areas. We don't know about the behavior and like function of sine x minus cos x. We don't know about them. We do not have geometrical knowledge about these. So that's why we use integration here.
Oh, okay, sir.
For any function, you can find the area under that curve for any function. If it is observed function like this, okay. So we cannot learn the specific formulas and results every time. That's why we learn the tool that how we can find out things.
So in NDA Max, everything will be based on integration or only few chapters, sir?
Few chapters.
Okay.
I was thinking to drop that chapter.
No, not like that, sir. Because I was seeing integration from first, so that's why I'm asking.
Okay. Integration is easy. Just you have to learn the formulas. Otherwise, it's easy.
Okay.
Yeah. Now. So this is our circle, and there is also a straight line. This is a straight line. So this straight line is x is equals to √3 of y. This circle is x square plus y square is equals to 4. Now radius is 2. We have find out this intersection point, that is 1 and √3. For x is equals to 1, y is 1 by √3. No, actually the intersection point was not this. It was, where is the calculation? Yes, it was √3 and 1. It was √3 and 1 and -1 and -√3. √3 was the value of √3 and 1. For 1, for √3 being the x, y was 1. Here for √3 being minus of √3 and minus of y. So this is a circle. Okay, if we draw a perpendicular here, so we know this coordinate, this straight on this particular straight line which is parallel to y-axis, the x coordinate here also will be √3. The coordinate will be 0. So if this is √3, so this distance is √3, and if this coordinate, and if we draw a perpendicular here, so this distance is 1. Now we have this right angle triangle, and there is this area under the curve also. So simply let's find out the area of sector. Here now we have situation like this. This is the part of circle which is known as sector. You must be aware about that. And we know about this right angle. There's a right angle triangle. Its base is √3. Side is 1. So from trigonometry lessons, we have learned that tan theta, if theta is discussing about this. So perpendicular, which is the arm which is just in front of the theta, which is 1, and by √3. So tan theta is 1 by √3 when on which degree of angle tan is 1 by 3. Please unmute yourself. Speak. Okay, no problem. But you should learn it. Tan theta is 1 by √3 when on 30 degrees. Okay. So now the area of sector formula says theta by 316 to pi by r square. So 30 degrees upon 360 degrees into pi r square. This will cancel, 0, 0 cancel, and 12. So basically pi into r is what? 2. So r square is 4 upon 12. So the area of sector is pi by 3. So this whole area of sector is pi by 3. Okay. Now the area of right angle triangle can be found out by easily half into base into height. Base is this, height is this, so √3 by 2. Both the questions are solved in just a minute. Okay, I'll just explain this much. Otherwise, it's a 1-minute question.
Okay.
Clear?
Yes, sir.
Let's go ahead then. How many questions we have? We have to complete them in today's class itself. So there are two curves, y is equals to sin x, y is equals to cos x. So let me just take the graph from the answer itself. So this is x-axis, sorry, y-axis, on which x is equals to 0, and x here is representing radians, okay, angle. So here 0, x is equals to 0. Here x is equals to pi by 2. Here x is equals to pi. Here x is equals to something. Maybe it's 3 pi by 2. Yeah, it is 3 pi by 2. Here it is 2 pi. So it is like that. So this particular curve is for y is equals to cos x. On cos 0 is 1. So that's why the curve is here. And sine, this curve is for sine x. So this will be on 0. So these two curves are like this. And if this is not clear, let me draw it also. This is y-axis, f of x. This is f of x. This is representing x-axis. Yes. No. Now, yes. So, for let's take pi by 2 value here pi. Are you understanding what is pi by 2 and pi?
Sir, is it degree or?
Yeah, it's a degree. Like
Okay.
pi is a radian. In degrees, it is 180 degree.
180.
Yeah, pi by 2 will be 90. So this is 0. So let's first talk about y is equals to cos x. Cos x. So for cos 0, the value should be 1. 1. So the cos x should be, the cos x curve should be here. For cos pi by 2, it is 0. For cos pi, it is minus 1. It should be here on minus 1. Cos 3 pi by 2, it should be here 0. 2 pi, it should be here again on plus 1. Right. So cos x graph is parabolic in this manner. Let me use my drawing skills. I got something like that. Something like that. That. Yeah, successful. Almost. Now. So, okay. This is cos x. Now let's discuss about the graph of sine. On sine 0, it is 0. So it will start from here. On sine pi by 2, it is 1. On sine pi, it is 0. On sine 3 pi by 2, it is minus of 1. Sine 2 pi, it is here. So graph should be something like that. Now the question says, this is the graph of sine x. Now the question asks that these are two curves. Okay, we have drawn them. What is the area of the region bounded by the above two curves and the line x is equals to 0 and x is equals to pi by 4? Okay. So x is equals to 0 means y-axis. So this is the y-axis which we are talking about. So x is equals to 0. Okay. And x is equals to pi by 4. Pi by 4 and this point on which these two curves are meeting. So this is a point of pi by 4. Why? On pi by 4, cos pi by 4 value is what? Sin pi by 4 value is what? Sin 45 and cos 45 both are 1 by root 2. So they are having same value on this particular point. So this should be our line. Okay. Now the area bounded by sine x and cos x, and these two lines should be this, where the line is here, cos x and sine x is here, and this line is also touching this area on a single point, right?
Yes.
Let's go back to the question. Look, there was a line x is equals to 0. So this is a line x is equals to 0. This is line x is equals to pi by 4. And these are two curves, cos x and sine x. So the area bounded by all of these is this only. So how we can find out this? So if the area is like touching the y-axis completely, so it would be convenient if we take the function in terms of y. And, so the function is what here? Y is equals to cos of x, y is equals to sine of x. So first finding out the area under this curve till this point of cos x. Let me do it using other pen. So the area under the curve cos x with y till this point, pi by 4. And then further, we'll find out the area under the curve sine of x from this point to this point. So which is, what is this point? This is 1 by root 2. Okay. So what we are going to do, we are going to first find this area and then we can add them, right? Are
Yeah.
you with me?
Yes.
Yes. Yeah, so finding this function in terms of x is equals to cos inverse of y. This would be x is equals to sine inverse of y. Now integrating, now find out this red area. So let's use red pen then. Red pen and cos inverse of y into dy from where to where? 1 by root 2 to 1. Okay, cos inverse integration is 1 by square root of 1 minus y square. This is the one. Negative sign. 1 and 1 by root 2. So first finding out for 1, finding out y for y is equals to 1. So it will make it a 1 by 0, which is undefined. So what should we do now? This is making it as undefined. We will not be able to find the area using this. So let's use some other method then, right? Okay, so now let's try some other method. Now what we can do other than this, there is another method. We can find out using representing these functions in terms of x only, and we will do so by we will do what? We'll find out the area under this curve cos x, and then we'll subtract it by the area under the sin x curve. We'll find the red shaded region, then we will subtract the blue shaded red. Okay, this is our game plan. Now let's integrate cos x into dx from where to where? Going back 0 to pi by 4, right? 0 to pi by 4 minus sine of x from 0 to pi by 4. Is this clear why we are subtracting?
Yes, sir.
So minus or sine pi by 4 is 1 by root 2 and this is 0. No use. Minus cos pi by 4 is minus 1 by root 2 minus cos 0 is 1. So minus half minus 1 by root 2 minus 1 by root 2 minus plus. So solving this further, 1 minus 2 by root 2. So make it 1 by 1 minus root 2 should be our answer. 1 minus root 2. Okay, 1 minus root 2 was our answer. Now this is we were finding the area. So 1 is this and root 2 is 1.41. So it's coming out as negative. So we'll take the modulus because area is always a positive. So after taking modulus, it will become root 2 minus 1. Okay, so the option A should be the correct option. Yeah, it is the case. Now going back, and what is the area bounded by the above two curves in the line x is equals to pi by 4 and x is equals to pi by 2. X is equals to pi by 4 and x equal to pi by 2. So let's draw another line. X is equals to pi by 2. So this is a line x is equals to pi by 2. Now we have to find out the area bounded by these two lines and these two curves. So the area should be this, right? And according to symmetry, it's my guess the answer should be root 2 minus 1 only, because it's a symmetrical function. Otherwise, if you don't have that much feel of functions in graph, then we can solve also this. For this, we'll first find out the area under this blue, and then we'll subtract the area under the red. So area under blue is what? Sin x, and then minus of cos x, then minus of cos x. And from pi by 4 to pi by 2. Right? Are you able to understand that what we have done here?
Yes, sir.
Yeah. So integration of sin x minus cos x. So it will give us the same function. Anyways, we'll just multiply it by negative. So negative of minus sin x will become sin x. This negative sign will become positive, and cos x. Right? And the limits are changed. Limits are different, pi by 2 and pi by 4. Pi by 2 and pi by 4. Let's first put pi by 2. Sine pi by 2 is 1. This is 0 minus sine of pi by 4 1 by root 2 plus cos 1 by root 2. So this is also 1. 1 minus 2 into root 2. So this will become 1 by root 2. 1 minus root 2. Taking modulus root 2 minus 1. This is the answer. Is this clear?
Yes, sir.
So by using symmetry and by using just our eyes, we could also mark the answer. Let's move on to the next question. This is the last question, I guess. Yes. So this is a very simple question. I can also give this to your homework. What you have to do is simply draw the graph wisely. These are all straight lines because it is having degree 1. This is also a straight line. This is also a straight line. This is also a straight line. So just draw these straight lines carefully. How will you draw two straight lines? Simply let x is equals to 0, then find out for y. Then y is equals to 0, then find out for x. And after finding these 2 points, you can draw these 2 points. These two, you can plot these 2 points. And after plotting these 2 points, just meet those 2 points, and you'll be having a straight line. Similarly, do all for all, and you will be having a figure like this, and find out the area found between them. So if you have any doubt, you can ask me in next class. Okay,
Okay, sir.
take a snapshot of.
Yes, sir.
Yeah. Any doubts? Any other doubts?
No, sir.
Any questions?
No, sir.
Okay, review or feedback suggestion for me.
No, sir. Everything was good today.
Great. Thank you. Good evening.
Thank you, sir.